So we're going to get into the actual meat of the course now. The name of the course is Solid State Devices, which deals with semiconductors. Well, what we're going to look at now is not in the text. We're fixing to start working in Chapter 5, but we're going to get a little brief. Yeah, Chapter 5. We're not going to do Chapter 2 and 3. We're not going to do the first 4 chapters because it doesn't deal with semiconductors. But there are some good chapters. This book has a lot of good information in it. It's just that we're not going to cover all the stuff that's in there. So before we can understand semiconductors, we got to understand a little bit about atomic structure and what makes something a conductor and what makes something an insulator and what makes something a semiconductor. Hopefully everybody knows what voltage is. What's voltage? What's the voltage source? What does the voltage source do for? What does the voltage source do for us? Provides a push. Well, technically we call it a difference of electrical potential. So we can't have current flow unless we have push. Everybody understand that? You can't create a force unless you have a pressure. Because force is equal to area times pressure. So we can't have a force without a pressure, right? You understand? So voltage is our pressure. If we didn't have voltage, we don't have current flow. If we don't have current flow, we don't have a force. If we don't have force, we don't have motion, we don't have work. What's a conductor? Well, technically, yes and no. Technically, a conductor carries current. Carries current between the voltage source and the load. Which results in power. What's an insulator? Something that has an extremely high resistance. There's no such thing as infinite resistance, by the way. That does what? Impedes the flow of current. So it don't let current flow, even though there is current flow through the insulator because it does have some resistance, but it's so small it doesn't cause effect. The main function of the insulator is to keep the pushing. And I think we talked about the pipe. So the inside determines how much water we can put through it. The thickness of the wall determines how much pressure it can keep in, right, without busting. What is a semiconductor? So is a semiconductor a conductor? No. So a conductor has almost no resistance. You can't say it has none. An insulator has extremely high resistance. And a semiconductor is going to fall exactly in the center of both of them. So we don't classify it as an insulator. We don't classify it as an inductor. And we'll look and see exactly how it's counted. What are the most commonly used conductors? We've already talked about that. Aluminum and copper. What are the most commonly used insulators? Probably the most common insulator is air. Yeah. Then we have any rubbers. Rubbers are real good. Teflons are good. Plastic are pull. Thermoplastics, they have different types of combinations. These make extremely good insulators. I could say H2O. I could say H2O. I mean, that's water. I could say oxygen and nitrogen and then a bunch of other garbage. This is air. Air is a really good insulator. Well, they don't get shot because they're not across a difference of potential. They're not across. Well, don't even have to be grounded. You can go up there and you can swing on one of those electrical wires. It's not going to hurt you. But if you get between two of them, that's where you're going to get hurt. You can't conduct with one wire. So birds don't get electrocuted because they're only on one wire. Squirrels can run across it because they only get one wire. We do kill some squirrels at the transformers, at your house transformers, because they'll be on one lead and they'll reach over on the other one and then they're gone. Yeah, well, we at the transformer. Yeah, but it's an insulator. Paper's a good insulator too. It's just that paper is so flimsy. And ground and the neutral wire carries no potential. The neutral wire carries no potential. The ground is not even supposed to carry current. So it doesn't carry a potential. It's not supposed to carry a current. The ground only carries a current when you got a problem, a bad problem. Well, it blows the breaker. It should pop your breaker. What are the most commonly used semiconductors? We'll find that out. Silicon and germanium, the two most. So what determines if an element is a conductor, an insulator, or a semiconductor? And that's what we're fixing to talk about. So these are our conductors. These are our conductors of electricity. They're mostly metals. And you can see by far the best conductor. Most people, when you say what's the best conductor of electricity, they say gold. Because it costs a lot of money. Right? Yeah. So the best conductor of electricity is silver. We don't use we use silver as a plating on contacts, but we don't use silver as a conductor because it's very expensive. The second base conductor is copper.
You use that as a tricky question because a lot of times on your test, you'll have that, what's the best conductor? I put silver down there and it's copper every time.
No, it's not. The best will be silver. I can show it. Wherever you want to go back to, we'll go back.
I got the same thing, and after it was over with, I'm like, he said,
So be careful.
It is a trick question. Silver is one of the
You won't admit it.
No, I won't. It says I understand the way people want the way people want multiple choice questions is like what color is red, and the answers would be green, red, black, and blue. That's the way you want. That's the way you want a multiple choice question. Multiple choice questions, the answer is there. So what we got to do is we got to prove that you know the answer. So once you've been teaching a long time, you understand the wrong answers that people give. And then those will be the other options. And they're not in there to be tricky. They're in there to prove that you know what they are. If you think those questions are tricky, wait till you look at some of the Siemens tests.
I think it just proves that you don't know how to read.
You don't read. And the problem is
too much into the question.
Well, the problem is people, and I don't know what to do about that, guys. I do it myself. You got something in your mind, and that's what you read. And then you go back later on, like Larry did, and it's not what it said. It's just that, but you could have swore that's what it said.
That's what I interpret.
Well, it depends on what you're talking. In power transfer, the aluminum's most common. In electronics, copper is the most common. Yeah, so it's a toss up on which you're talking. So power transmission is aluminum. They do. All your downdrops are still aluminum. By the way, aluminum and copper are dissimilar metals. The big problem we have with aluminum is it oxidizes real fast, which means it rusts real fast. Aluminum oxide is an insulator. The problem we have with mixing copper and aluminum is they're dissimilar metals. And what happens when you mix dissimilar metals, they set up something called electrolysis and they will eat themselves up. So if you're going to mix copper and aluminum, there's a paste you buy. It's an antioxidant that you coat the aluminum wire real good with, and you can mix them all day long. And then make sure if it's outside that you tape it up real good. So if you have the opportunity to get into one of these down drops, where the down drop is aluminum and they connect it to the copper, if you pull that tape off, there's going to be this brown goop in there, and that's that antioxidant. You can buy it at Lowe's. You can mix that. You got to be real careful because a lot of your older houses, my son's house, I never forgot when it was built with aluminum wire. Aluminum, yeah. And the wires running down through there might be aluminum. They might be copper. Huh? No, but he's got aluminum wire. And I told him about the antioxidant, but he understands that, and you can still buy aluminum outlets at Lowe's. All your receptacles and everything you can buy aluminum.
My grandmother's had that.
Yeah. And of course, when you blow, what do? You get a piece of aluminum foil and wrap it around there and screw it back in.
That's legal to do.
Yeah.
Until.
And these are the other metals. So we use silver as a coating. So if you, contacts, like light switches and stuff like that, where you're making a circuit just by touching two conductors together, the contact point will have a thin silver plating on it. And now what's nice about silver oxide, it's just as good as conductor as silver is. So even though it oxidizes, but it's a real thin coating. So if you get in there with a file and sand it off because it looks gray, then you get down to copper, and copper oxidizes real fast too. So copper oxide is a insulator, or copper rust is an insulator, but it doesn't corrode near as fast as aluminum. Another problem we have with aluminum is it's got a real high coefficient of expansion and contraction, which means it changes gauge a lot with temperature. So you really got to tighten those things down, because if you don't, they'll work themselves loose. An atom consists of two main parts. Hopefully this is a review. We call the inside part, we call the what? The nucleus, and then we have electrons that orbit around the nucleus in shells or bands. So the nucleus consists of two parts. It consists of protons and neutrons. The proton carries a positive charge. The neutrons are not charged, but the only thing they do is add to the weight of the nucleus. The electrons have a negative charge. The protons have a positive charge. These things attract each other, so the electrons are orbiting around, right? You understand? Everybody okay so far? Repeat, right? Electrons and protons have the same net charge, but in opposite polarities. Since opposite charges attract, the electrons orbit around the nucleus. Since electrons and protons have equal opposite charges, a balanced atom has no charge. But if we lose one of those electrons, then we have something called an ion, which we'll talk about in a minute. Electrons are grouped in energy bands called shells or energy levels. Electrons in shells near the nucleus have less energy. The electrons with the highest energy are in the outside shell or outer shell. The outer shell is the only one that has a name. The outer shell is what we call the valence shell. The electrons in this shell are called valence electrons. Are we okay so far? Yes or no? If an atom has one shell, the maximum number of electrons is 2. After the first band, the valence shell can hold a maximum of 8. So one shell, we can have weird things. But if we get 2 shells, that second shell becomes the valence shell, and the maximum it will ever hold is 8 electrons. And be balanced. Are we okay so far? This determines what category this falls in. This determines whether it's an insulator or a conductor or a semiconductor.
Will it always be an even number of electrons?
No. But the maximum, the minimum would be what? 1. The maximum would be 8, and anywhere in between those. Good question.
Well, you said balance. I thought you had to.
No, balance, the maximum it can hold is 8. Balance means it has the same number of electrons as it's got neutrons. So it means not neutrons, protons. So if you had 1,000 protons, you would have 1,000 electrons. That would mean, and those bands go in scales, and we don't have to, and I don't know if you took either chemistry where you had to, did you have to learn that? The shells, and how much each shell would hold before it bumped up to another shell? Yeah, I know, and that's why. So all we need to do is understand that valence shell. If the valence shell gets enough energy, it can escape. If a valence electron gets enough energy, it can escape from the valence shell. The escaped electrons are called free electrons. Thank goodness for free electrons, because that's what current is. The process of losing or gaining is called ionization. So now, if we lose an electron, it's going to the atom is going to have a positive charge, right? You understand? If we gain an electron, then the atom is going to have a negative charge.
So what happens when you deionized?
Well, deionized would be you're making a balanced electron. So now you're making the electrons and the protons match. Are we okay? So a negative ion indicates we have lost an electron. A positive ion indicates we have gained an electron. Are we okay? Atoms with 3, 2, or 1 electrons in the valence shell make good conductors. Atoms with 4, 5, 6, 7, and 8 electrons. Of course, the ones with 1, these are the best conductors because they can get rid. Huh? 4 don't go either way. So 5, 6, 7, and 8, these make good insulators, with 8 being the ones. This guy's fat, dumb, and hammy, right? It's right there where it needs to be. Atoms with 4 electrons in the valence shell are not good conductors or insulators and are commonly referred to as semiconductors or germanium or other ones. We have all kinds of semiconductors. Usually we like to use the ones that are solid. So we do have atoms that would make good conductors, would fall into the conductor category, like hydrogen. Hydrogen's got 1 atom out there. But the problem is it's a gas, right? You understand that. So we're talking about, to be conductors are usually metals that fall into this category right here, like gold, silver, copper are in this category right here. What's that? They've been trying to come up with technology transfer. We can transfer power through the air. We just can't transfer much power. Probably because of other things. I'm not really sure. I'd have to do that. That's a good question.
Because, I'm kind of curious. Air's supposedly the best insulator.
Well, it's not the best insulator. It's an insulator. It is an insulator. Yeah, when we start talking about insulation, we start talking about what they call a dielectric constant. A dielectric constant is one would be pure air without having any contaminants inside a vacuum, and that's what 1 is. So if it's got a dielectric constant of greater than 1, that means it's a better insulator than air. If it's less than 1, it means it's a worse insulator than air. So yeah, there's insulators out there that's better than air, but air itself is a pretty good insulator. Are we okay? Yes or no? So this is the periodic table. And of course, these are your semiconductors right here. Notice they fall in a group. I'm sorry. These are your. What time does this class get up? 12:30, right? These are your good conductors right here. So there's copper, silver, gold. I'd have to look at that. And then this guy's over here. This is aluminum. So I think aluminum has like 3 in the outer shell. I've got another one somewhere. This might be on here, where it actually gives here's our semiconductors. Carbon is a semiconductor, silicon, germanium, tin, lead, and this is pretty interesting. This is our solder is made out of this, and this is I can't read that. It's carbon. Carbon was the first semiconductor that was used. Originally, when we set up carbon is a unique atom in that it actually changes its opposition depending on how much it's compressed. The original voltage regulators were what they call carbon pile regulators. So what they did on carbon pile regulators is they had a big spring pushing them together, and then when the voltage tried to go up, it had a solenoid out there and it would pull them out, and cause the resistance of the carbon to go up. If the voltage tried to go down, go in and cause the resistance to the carbon. And carbon pile regulators are still out there. You can still, voltage regulators, you can still go up and research for them and see carbon pile voltage regulator. The problem with carbon though, we use it as a semiconductor. We used carbon resistors were the first resistors. And of course, the problem with copper is that it varies its resistance a lot with temperature, so we don't see much pure carbon resistors anymore. But the original resistors were carbon. All they did was took it, they compressed it down to the resistance they wanted. They put 2 leads in, compressed it down on there. They coated it with some paint and put some colors on there. Huh? It was real neat because you could trim them by taking a file. We used to do that. You just take a little V-neck file and you could set that resistance to about anything you wanted to. Huh? We used to do that on some of the transmitters over on. They had a structure mill, and the cranes had so they could open the doors on the furnaces, and those were RF, and RF frequencies got to be perfect, and that's the way we used to trim those frequencies. We'd take those resistors, and we'd take that, and then we'd coat them with insulating paint. So this is where we're at this is it right here, guys. So this is showing the valence electrons, and I don't know. I'm gonna back out of this and zoom into it a lot. So this shows the bands. So how many we see here? 1. How many we see here? 1. How many we see here? 1, 1. Right? See that? These would make good conductors. This would make a good conductor. This would make a good conductor. But what we usually use metals, right? You understand? When I get into aluminum, look at aluminum. It's got what? 1, 2, 3. So this guy's barely a conductor. But why? It's cheap, and we step the current with a voltage up so high that the current goes down that we could afford that. By the way, rule of thumb is that you increase the gauge size, not the number. Gauges are kind of strange. As the gauge size goes up, the gauge number goes down. So that means a wire that had a 0 gauge would be pretty big. A 24 gauge would be real small. So that's a gauge number. So we can go up to the next higher gauge. The next lower gauge number, and use aluminum instead of copper. That's rule of thumb. It would have approximately the same resistance over the same length. But now it would cost a lot more to support it, right? And they have higher resistance. So this guy here has 3. When we come over here and look at the semiconductors, what would we see on that?
5, 6, 7, 8.
No, not a semiconductor.
Oh,
4. So all these, if I can zoom in close enough. So these would be our semiconductors. So everyone that falls in this group right here, these are semiconductors. So here's carbon, it's got what? 4. Here's silicon, it's got what? 4. Here's germanium, it's got 4. And then these other ones down here. These are the 2 possible. Gallium is down here too. Gallium is used in light emitting diodes. We're counting the outermost ring, which is the valence shell. So the only one that comes into matter when we start talking about conduction is this outer ring right here. So this is the valence ring right here. See that, Jackson? So this has how many? 1, 2, 3, 4. We're not worried about the inside rings. All we're worried about the outer ring or the outer shell is called the valence shell. The valence shell is what determines if it's an insulator or what determines if it's a conductor and what determines if it's what we call a semiconductor. So if it's got 4, it's a what? Semiconductor. If it's got less than 4, it's classified as a conductor. If it's got more than 4, it's classified as an insulator. The best conductors have what? 1. The best insulators would have what? 8. So our real good insulators, we're going to look at some type of combination or some type of material that's got 8 out.
What is there?
Air is a weird thing because it's not an atom, it's an element. So well, but it's made up of molecules, right? So it's made up of a combination of different things. So air is a good insulator, but we can't say okay, it has 4, it has 8 because it's made up of what? Primarily, it's made up of what's the 2 gases? Oxygen and nitrogen. Okay, so this little thing we're talking about don't come into play. Oxygen, nitrogen, and then a bunch of other carbons. So we don't have pure air unless we run it through a lot of filtration. So we breathe in a lot of stuff.
Yeah.
So this is where we're going to move in, guys. This guy right down through here, these are our semiconductors. And we're going to start doing something called doping. So right now this guy it's not an insulator and it's not a conductor. So this guy could be used as a resistor. We use them as resistors all the time. Right? You understand that? On printed circuit boards or in integrated circuits, you won't see any real resistors. It'll just be silicone that they can vary the width and the height to get a resistance. But what we're going to learn next class is I can deliberately introduce other atoms into this and form molecules, and we can control the conduction. We can control the conduction, which is pretty neat. Those are where we call them semiconductors, but they are literally doped semiconductors. Are we okay? All right, guys. Y'all have a good weekend. Somebody I'll see y'all tomorrow. Somebody I'll see y'all tomorrow night. Savannah's in all my classes, so it's okay. So now we're fixing to move into chapter 5. Chapter 5 starts with semiconductors.